Today we're diving into a paper that explores a potential vulnerability in the safety mechanisms of large language models, LLMs. The paper, Jailbreaking Large Language Models with Symbolic Mathematics, proposes a novel technique called MathPrompt that leverages LLMs' mathematical capabilities to bypass their safety measures. Let's start with the basics. What are the primary safety concerns associated with LLMs?
The main concern is that LLMs, despite their impressive capabilities, can be manipulated to generate harmful content. This includes generating misinformation, hate speech, or even instructions for illegal activities. Current safety mechanisms, often based on training with aligned data and reinforcement learning, aim to prevent these outputs.
So how does MathPrompt exploit this vulnerability?
MathPrompt takes advantage of the fact that LLMs are increasingly adept at understanding and manipulating symbolic mathematics. The technique involves encoding harmful natural language prompts into mathematical problems, which are then presented to the LLM.
That's an interesting approach. Can you elaborate on how these harmful prompts are encoded into mathematical problems?
The paper utilizes concepts from set theory, abstract algebra, and symbolic logic to represent the meaning and structure of the harmful prompts. For example, sets can be used to represent categories of actions, while group operations can model sequences of actions. Logical predicates and operators can be used to express conditions and relationships between actions.
So the LLM is essentially tricked into solving a mathematical problem that, when translated back into natural language, reveals the harmful content.
Precisely. The LLM, trained to be proficient in mathematics, may not recognize the encoded prompt as harmful, leading to the generation of unsafe content.
That's quite clever. What were the results of the experiments conducted in the paper?
The experiments were conducted on 13 state-of-the-art LLMs, including models from OpenAI, Anthropic, and Google. The results showed that MathPrompt was highly effective in bypassing safety mechanisms, with an average attack success rate of 73.6%.
That's a significant success rate. Does this mean that all LLMs are equally vulnerable to MathPrompt?
The paper found that the vulnerability was present across all tested models, regardless of their size, training paradigm, or safety settings. This suggests that current safety measures are not robust enough to handle mathematically encoded inputs.
That's concerning. What does this tell us about the limitations of current LLM safety mechanisms?
It highlights the need for more comprehensive safety measures that can detect and mitigate potential harm across various input modalities, including symbolic mathematics. Current safety mechanisms, primarily designed for natural language inputs, may not generalize well to mathematical representations.
So how can we improve LLM safety in light of this vulnerability?
The paper emphasizes the importance of expanded red teaming efforts, which involve systematically identifying and addressing vulnerabilities. This includes testing LLMs with a wider range of input types, including mathematical representations.
It seems like a holistic approach to AI safety is crucial. Are there any other potential vulnerabilities that need to be addressed?
Yes, there are other potential vulnerabilities that need to be considered. For example, LLMs can be manipulated through adversarial prompts, input obfuscation, or exploitation of linguistic variations. These vulnerabilities require ongoing research and development of robust safeguards.
The paper also mentions the importance of embedding analysis. Can you explain how this analysis helps understand the effectiveness of MathPrompt?
Embedding analysis involves examining the semantic representations of the original prompts and their mathematical encodings. The paper found that the encoding process significantly alters the semantic representation of the prompts, making them less recognizable to safety mechanisms.
So the mathematical encoding effectively disguises the harmful content from the LLM's perspective.
Yes, the embedding analysis suggests that MathPrompt doesn't simply obfuscate the original text, but fundamentally alters its meaning in the LLM's understanding.
To wrap up, can you summarize the key takeaways from this paper?
The paper demonstrates that LLMs are vulnerable to jailbreaking techniques that exploit their mathematical capabilities. MathPrompt, a novel technique that encodes harmful prompts into mathematical problems, achieves a high success rate in bypassing safety mechanisms. This highlights the need for more comprehensive safety measures that address diverse input modalities, including symbolic mathematics.
This is a fascinating discussion on the potential vulnerabilities of LLMs and the need for robust safety measures. Thank you for your insights.